Given angle alpha in standard position with its terminal arm in quadrant 3, and cos of alpha is negative 3/5. And angle beta in standard position with its terminal arm in quadrant 2, and sine of beta is 1/3. Determine the exact value of sine alpha plus beta. Initially, the first time you read this question, I think this has the biggest scare factor. This sounds like the hardest question you have ever done in this class. There's so much involved here. I will tell you that once you recognize this question, it is very straightforward and easy to do. In fact, I give it a name. I call these questions double triangle questions. And what's going to happen is you're going to see a question like this and you're going to say, oh, it's a double triangle question. And because you know what to call it, it also tells you the strategy that we're going to use to solve this. We are going to draw two triangles to solve this. So first, there's always going to be enough information for you to figure out and draw a triangle for alpha and a triangle for beta. So we'll start with our alpha triangle. We know that alpha is in quadrant 3, so you can draw the angle in quadrant 3. And you always draw your triangle back to the nearest x-axis so that you can label your reference angle. There would be our reference angle for alpha. So when we draw a triangle, it's always back to the nearest x-axis so that it involves our reference angle. When you have your reference angle, we know that cos of alpha is negative 3/5. That would mean we can label adjacent over hypotenuse as 3/5. Even though cos of alpha is negative 3/5, for me personally, I like to label all my sides as positive numbers. You will see if you watch someone do this on YouTube, sometimes you'll see them label the 3 as negative because it's going 3 to the left. But I like to think of it as like this length is 3. So if that length is 3, I label it as positive 3. I use my CAS rule always to double check whether things are positive or negative in the end. A squared plus b squared equals c squared. Maybe you recognize this as a very famous 3, 4, 5 triangle. 25 minus 9 is 16, square root of 16 is 4. So you can do a squared plus b squared equals c squared to find this out. And with the double triangle, we already knew that cos of alpha was negative 3/5. We can now use the triangle and figure out that sine of alpha is negative 4/5. Next, we can draw our beta triangle. We are told that beta is in quadrant 2. Draw to the nearest x-axis, so you can label your reference angle for beta. We know that sine of beta is 1/3, that's opposite over hypotenuse. And a squared plus b squared equals c squared. We'll let you figure out that that other side is the square root of 8. This lets us, well, we already knew that sine of beta was 1/3. Now we can label cos of beta negative because it's in quadrant 2 will be negative square root of 8 over 3. Now we want to find sine alpha plus beta. And on our formula sheet, sine alpha plus beta is sine alpha cos beta plus cos alpha sine beta. And in order to figure this out, the two triangles that we have given us the information to plug things into the next step. And at this point, I always take a survey because I found out from years of teaching that whether I teach this to you right now really doesn't matter. What you will do in the next step for this question, the first time you have to do this question on your own, it will not matter. Even if I showed you the right next step, you will go with your gut on a quiz or a test, and you will write exactly what you're going to write right now. And about 50% of you are going to make a mistake. And it didn't matter. First, I thought, oh, do I have to teach this a better way? And I tried, and I found out that the best way for you not to make this mistake is to try it right now on your own. I'm going to do a survey. Most classes are around 50%. Morning class, they did pretty well. They're about 60% did it right. That's higher than normal. Okay? But what you write as the next step will be exactly what you write as the next step if you had to do this on a test, even if you had been taught the right way. But if you make a mistake now, you will learn from it, and I can't say this 100%, most likely won't make the mistake again. There are some of you that'll be like, I made the mistake, you showed me the mistake, Mr. JR, you told me to pay attention, I did, and I did it again on the test. That happens. But you've got the information from the triangles here. Your next job is just to write the next line, plugging things in where they belong. And I will take a survey and find out this class's percentage. So the correct way to do this is to substitute for sine alpha. You have to realize you don't know alpha. Nowhere did you figure out what alpha is. But you know that sine of alpha is -4/5, so we replace the whole thing. The wrong way, and this is very typical, because you are so used to, when you substitute, you're used to substituting for a variable. So you want to just plug something in just for the alpha, because that's how you've always substituted. You substitute something for a variable. But you have to realize you do not know, this is wrong, you do not know what alpha is. Nowhere did we figure out alpha. We know that all of sine alpha is equal to -4/5. So we have to do the big substitution. And all of cos beta is equal to -√8/3. And all of cos alpha is -3/5. And all of sine beta is 1/3. So as soon as you keep writing the sine and the coses, that's the common mistake. And it's easy to do because you're used to substituting in just for a variable. Okay? So, if you did it right, chances are then that would mean you would do it right on the test. If you did it wrong, if you don't pay attention right now and say, oh, I understand why I did it wrong, you would have made that mistake on your test as well. Okay? It's very rare, but it does happen that people do it right now, and then they get to the test and do it wrong. Like, oh my goodness. More typical is you do it wrong now and you didn't pay attention and do it wrong again. Not much I can do about that. But most likely now you'll be able to do this right. And to write this as a final answer, we always need to write our answers as a single fraction. So if I multiply these together, the bottoms will be 15, the tops will be +4√8. Multiply the tops here, I'm going to get -3/15. I have a common denominator, so my final answer for this question will be 4√8 - 3 all over 15. And you don't need a calculator for this, and all double triangle questions are always the same. They're usually worth 3 or 4 marks on a test. So students like them because if you recognize the double triangle question, you're like, this is easy marks to get because I just have to follow the steps. I've already pointed out the most common mistake, or you pointed it out to yourself if you didn't. So hopefully that doesn't happen on the test. So questions for practice on this one are 8 and 13.